All right, we are live. Let me know in the chat if you can hear me. If you can, welcome. This is our free lesson for Algebra 2. Today we're going to be talking about quadratic systems of equations. Super exciting. Before this lesson, we've talked about systems of equations using elimination, substitution, things like this. But now we're switching it up a little bit, bringing in those quadratic equations. So we're about to have a lot of fun today, but let me know in the chat. Give me a plus if you can hear me. And go ahead, check out the description in the description of this video down below. You'll see that very first link is a link to our PDF. It is a workbook that will help you follow along in today's lesson without having to copy anything down from what's already on the slide. So we can focus on the learning and not, copying something correctly or not from the board or from the screen in this case. You will have to subscribe to chat today, so make sure you do that as well to get the full experience with me here at My Ed Space. Let me introduce myself really quick before we get started. Hi, I'm Eddie. I'm the senior math teacher here at My Ed Space in the US. I've been teaching for 9 years in high school classrooms and college lecture halls. I private tutored every grade level from 6th grade math all the way to students in college preparing for grad school. So I have a really wide range of experience, and I know exactly what your Algebra 2 exam questions, things like this, how this would be taught in school, things like that. I know exactly how that looks like. And so I'm well equipped to help you succeed in Algebra 2 in the classroom. Not only that, I teach in a way where everything I teach in every course, it kind of builds on top of one another, so that I'm not just teaching to one type of question. I'm teaching true understanding of concepts, so that when you do see this again in future courses like pre-calculus, in AP calculus, in statistics, in AP statistics, in computer science, whatever it may be, you see these in familiar ways where you completely understand instead of just knowing when to use what formula, right? I try not to teach formulas as much. I tried to teach understanding so that you can come up with the formulas yourselves and see where it truly comes from. Now, during these live lessons, I believe in 3 things. My goal, number 1, is I want you to have fun. I'm going to have fun, and so I want you to have fun. Hopefully, I can communicate that through the screen, because when we have fun, we tend to learn better and remember things for a longer period of time. Number 2, I want you to participate. I want you to make mistakes, because when we fix our mistakes, that's when we truly retain and learn, retain information and learn. Brain research has showed that when you fix a mistake, you retain that information 10 times as longer. 10 times longer. I don't know why I said as longer, but 10 times longer. And in order to fix your mistakes, you got to make those mistakes first. Number 3, I believe in asking specific clarifying questions. If you're just asking, I'm confused, or can you do the problem again? The answer will be, I don't know how to help, right? Whereas if you ask me, on the second step, how did you get from 7 to 16, for example? Then I can help. I know exactly what to help you with. I know exactly what you might be struggling with. And I can, with my 9 years of teaching experience, I can kind of start to, help you understand what may have gone wrong as well and how you can fix it next time you see a problem like that. So without further ado, let's begin the fun. So from previous lessons, I like to start with something called an APK. It's called Accessing Prior Knowledge. We have learned how to solve linear systems of equations either by elimination or by substitution. In this case, we all know, in the chat, let me know, S for substitution, E for elimination. Which one would you use here for this system of linear equations? Would you use E for elimination or S for substitution? Let me know in the chat. Many of my students who have gone through this lesson already said overwhelmingly E for elimination, because it is quite difficult to isolate one of the variables here and then plug it into the other equation and solve that way. We'll be left with a lot of kind of messy things. So instead, what we're going to do is we're going to multiply the top one by a 2 and the bottom one by a 5. This gives us 6x plus 10y is equal to 6. The bottom one gives us 20x minus 10y is equal to 65. Now, what we can do from our previous lessons, what we learned, is that we can add straight down since the plus 10y and minus 10y eliminate. Again, eliminate meaning it becomes 0. Two things eliminate one another. So we have 6 plus 20, which is 26x, equal to 71. 6 plus 65 is 71. Now, to get x, we'll divide both sides by a 26. So now we have 71 over 26. Now that we have our x value, we can go ahead and solve for a y value by plugging in into either one of these equations. Now, I'm thinking 13 is quite a big number to work with later, so I'm going to choose to work with equation 1. However, let me ask you in the chat, am I allowed to use either one of these equations? Am I allowed to plug in this x value of 71 over 26 into either one of these equations? Yes or no? Do either of these equations, will I get the same y value when I plug in x equals 71 over 26? And the answer is absolutely. You can plug in 71 over 26 into either one of these x values, you get the same exact y value. We're just trying to work smarter, not harder, and think about which equation will be easier to work with. The second equation not only has a negative, but also a bigger number of 13, the biggest number here. So we're going to work with the first one. We'll say 3 times 71 over 26 plus 5y is equal to 3. And now our goal is to solve for y. 3 times 71 is 213 over 26 plus 5y is equal to 3. Now I am going to need a common denominator of 26. So I'm going to multiply 3 by 26 over 26. That will give me 78 over 26. So from here, I get 5y is equal to 78 over 26 minus the 213 over the 26. Now from here, I get negative 135 over 26. And we have a 5y. And when we multiply both sides by a 1/5 or divide both sides by a 5, I'll get negative 135 over 26 times 1/5. This 5 cancels in to this 135. We'll get 27. So we get y is equal to negative 27 over 26. We learned in previous lessons that whenever we solve a system of equations, we must put the solution in the form of a coordinate point. So we have 71 over 26, comma, negative 27 over 26. And this is the point where these two linear equations intersect. So now this was kind of a challenge problem before for us, working with elimination and substitution with linear systems of equations. But today, again, we are tacking on quadratic equations. Let's see how that goes. So, given a circle and a line, we may wish to find the point or points at which the circle and line intersect. In this case, I give you the graph this time, and we're shown that there are 2 points of intersection. So we need to make sure that when we solve this, we are left with 2 points of intersection and not just 1. How can we do this algebraically? We did mention in a previous lesson that that substitution is quite useful when the functions start to curve. And circle is a perfect example of an equation where the graph curves. So what I'll do is I'll substitute. Y is already equal to 2x. So I'll plug that 2x into this y. That becomes x squared plus 2x squared equal to 80. And now I solve for x. X squared plus 4x squared is equal to 80. When we add these up, we get 5x squared is equal to 80. X squared is equal to 16. And now here is where we need to lock in and pay attention to detail. When we take the square root of both sides of an equation, we must consider both the positive and negative values of that square root. X is equal to positive or negative 4. And that's how we know we get these two solutions, these 2 points of intersection, because x can equal either 4 or x can equal negative 4. And this is quite easy to solve because y is equal to 2x. y is equal to 2 times 4. So y is equal to 8 when x is 4. So 4 comma 8 is one of the points. And y is equal to 2 times negative 4. When x is equal to negative 4, y is equal to negative 8. So we have negative 4 comma negative 8. Now this looks somewhat symmetrical here. This is 4 comma 8. And this is negative 4 comma negative 8. And it makes sense from our visual, this graph that we see. So these do get really fun, right? These do get really fun. This was a easier example of this. It's not too bad once you think about it, right? It's just substitution. So give me a W in the chat if you're feeling good about this so far. Give me a plus if you're a little iffy. And if you have any questions, make sure to put them in the chat. I'm constantly looking at the chat, by the way. In our regular course, all the students are constantly chatting, asking questions, participating throughout every lesson. It's something like the average number of chat messages that students send per 55-minute lesson was like 30 to 40. Some students are at like 60 to 70 because they're there the entire time and just constantly participating and asking questions, and it brings this really engaging and safe learning environment. So I encourage you to do the same. You must be subscribed to my YouTube channel to chat here, but once you're on our platform and onboarded, you'll be able to chat through our platform where the stream is there and we have our own chat, which looks really nice and sleek. We have a dark mode on there as well, super exciting. But anyway, I digress. But let's keep going. I'm just so excited about this. Here we go. So solve 2x plus 6 is equal to y. Y is equal to x squared minus 9. So again, we can solve this by substituting. It's actually really nice here that the y's are already isolated for us. So we can set 2x plus 6 equivalent to x squared minus 9. So 2x plus 6 equal to x squared minus 9. And now let's put everything to one side, because whenever we have a quadratic equation, we may be able to factor. We may be able to factor. And so we have x squared minus 2x. When we subtract 6 from both sides, negative 9 minus 6 gives us a negative 15. So we're looking for two numbers that multiply to negative 15 and add up to negative 2. Those two numbers are negative 5 and positive 3. That's where we get x minus 5 times x plus 3 from. From here, a product of two expressions, when equal to 0, either of those two expressions can be set equal to 0, because 0 times anything is 0, and anything times 0 is 0. So I set x minus 5 is equal to 0, and x plus 3 is equal to 0, and now we solve. X is equal to 5, and x is equal to negative 3. Hi, Naya, welcome. So we have x equals to 5, y equals negative 3. I am now going to solve for y. I'm going to choose to work with the first equation because it's a linear equation, less likelihood of making mistakes here. I'm going to plug in x equals 5 and x equals negative 3. I get 2 times 5 plus 6 is equal to y. Y is equal to 16. When I plug in a negative 3, I get this. Negative 6 plus 6 is 0. So I have my 2 points, 5 comma 16 and negative 3 comma 0. Oh, Team Funny, can you not hear me? Inaya, can you hear me? You might have to... Oh, yes? Okay, great. You might have to change your sound settings, maybe? No voice. Interesting. Maybe use a different browser. Or, I mean, you can't hear me, so you can't. Yeah, maybe refresh. Thank you, Inaya. Thank you for helping him out. All right, great. So we have our two solutions, our 2 points of intersection. Again, that's what we're looking for whenever we're solving systems of equations. We are looking for points of intersections. Points of intersection. I don't know why I made the intersection a plural. All right. Let's keep it moving then. Let's check this one out. Should we rearrange for x or y here? We have 2x squared minus y minus 8x is equal to 0. X plus y plus 3 is equal to 0. Any ideas of how to solve for x and y here in the chat are welcome. In order to chat today, because we're on YouTube and not on our MyEdSpace platform, you will have to subscribe in order to chat. So keep that in mind. You do get the full experience by chatting as well. So yeah, looking forward to all the chatters here. Should we rearrange for x or y? Inai says y. I agree, but isn't there something nicer that we can do here? Do you notice something? When we rewrite this as 2x squared minus y minus 8x equal to 0, and x plus y plus 3 equal to 0, there's something really nice that happens here. Can't we just add straight down? The negative y and the y will eliminate. So we can add straight down, right? We have 2x squared minus the 8x. We're going to add the x, add the 3, and guess what? Now we have an equation where we only have the x variable. Great, Anaya. So we have 2x squared minus 7x plus 3 is equal to 0. Now, this is what we're thinking about. Whenever you have a leading coefficient to a quadratic equation that is not 1, this is how you solve it. We go 2 times 3. That is positive 6. So we're thinking of two numbers that multiply to 6, but add up to negative 7. Two numbers that multiply to a 6, but add up to a negative 7. Those two numbers are negative 6 and negative 1. So I put x and x, but I know one of these x's need a 2 in front of them. Now, which one of negative 6 or negative 1 is divisible by 2? The negative 6. So I put a negative 3 here instead, because negative 3 times 2 is negative 6, and that minus 1 here, and it checks out. So I get, great, negative 2x minus 1 is 0, x minus 3 is equal to 0, because again, we mentioned earlier that whenever we have a product of two expressions equal to 0, I can set either of those expressions equivalent to 0, because anything times 0 is 0, and 0 times anything is also 0. So here I have 2x minus or is equal to 1, x is equal to 1/2. Here we have x is equal to 3. So now those are the two x values for our 2 points of intersection. And I'm going to use the second equation to solve for my y, because I don't want to deal with any of those squareds up there. I'll get 1/2 for when x is equal to 1/2. I have 1/2 plus y plus 3 is equal to 0. So y will equal negative 3.5. Nice. And when x is equal to 3, I'll have 3 plus y plus 3 is equal to 0. So y is equal to negative 6. So our 2 points of intersection is 3 comma negative 6. These last couple portions here, it's just arithmetic. So that's why I kind of breezed by that. The most important part are these first couple parts where we're isolating, where we're combining the expressions, factoring, finding that x value. Whenever we're looking for the y value, the other value, whenever we're looking for the other values, then that's just simple arithmetic. Now, you actually did get them correct. Negative 7/2 is negative 3.5. So you're good to go. You got them both correct. Congratulations. Well done. All right. Let's try another one before we do a temperature check here. Let's try this one. So if x squared plus y squared is equal to 9, can anyone tell me in the chat what this looks like on a graph? What shape does this make on a graph? X squared plus y squared is equal to 9. What shape does this make on a graph? X squared plus y squared. That kind of looks like the Pythagorean theorem. A u? Okay, I understand that because we have that x squared there. But x squared plus y squared equal to r squared. I know this might look like the Pythagorean theorem to all of you, but that's exactly how we create an equation of a circle. So this is a circle with radius 3, because 9 is 3 squared. So circle with radius 3 is what this looks like around the center, the origin, the center at the origin. All good. That's what we're here for, right? Algebra 2, we're bringing everything that we've learned in geometry and Algebra 1 together, and that comes together with graphs, with equations put together, and we start to visualize things before we get into pre-calculus and AP calculus, where we need to know things like that just like in the moment, really quickly. Okay, in this case, it kind of looks like it's easier to isolate the y. So I'm going to move this negative y to the other side, becomes a positive y. I'm going to move the 3 to the other side, becomes a minus 3. Now from here, I am going to substitute. Y is equal to 2x minus 3, so I'm going to move that y into that little y right there. So now I have x squared plus y is now 2x minus 3. I'm going to square that, and that's equal to 9. I have x squared plus, now this is a very common misconception that students make right here, so pay attention. We have 2x minus 3 squared. That means we have that thing times itself, right? Times itself. A lot of students will just say this is 4x squared minus 9 or plus 9. We need that middle term as well. 2x times 2x is 4x squared. 2x times negative 3, well, that happens twice. 2x times negative 3 is negative 6x, and it happens twice. So it's minus 12x, and then negative 3 times negative 3 is positive 9. And this is all equal to 9. Well, guess what? The 9s will eliminate, leaving us with just 5x squared minus 12x equal to 0. So I have, let's factor out an x, because that's what each of these terms have in common. So x can equal 0. 5x minus 12 can equal 0, so x here equals 12 over 5. So our two x values, as Anaya is telling us in the chat, is x equal to 0 and x equal to 12 over 5. Beautiful work. Now, using our y equals 2x minus 3, I can solve for my y value, negative 3, so you have 0 comma negative 3. I can do the same for y equals 2x minus 3 here, so I have y equals 2 times 12 over 5 minus 3. But now I'm staying aware and trying to not do too many steps in one step, but also do the steps that I know that I can do between two steps. I know that my denominator now will be 5 for my y. 3 with a denominator of 5 is 15 divided by 5. Once I multiply both top and bottom by a 5. So now we have 2 times 12, which is 24, minus 15. That's 9. But all of that is still over 5. So you have 12 fifths, comma 9 fifths. If you like decimals, then this would be 2.4 over 1.8. And these are your 2 points of intersection between this circle and this line. And if you think about this graph, I'll quickly sketch it. Here's the circle with radius 3. Y equals 2x minus 3 means we're passing by at negative 3 right here, and we're going up 2 over 1. Something like this. So notice how we have 2 points of intersection. This one would be our 12 fifths, comma 9 fifths. And this point right here where we meet on the y-axis is 3, comma negative 3. And that's it. Let me get a quick temperature check in the chat. Again, in order to chat, you need to be subscribed to my channel. You can always unsubscribe after, but in order to get the full experience today, I would highly encourage you to just subscribe in order to chat. Give me a W in the chat if you're understanding this, maybe learning something new. Put a plus in the chat if this is still a little, a little iffy. You want to see a couple more practice problems, so that I can get a quick kind of check for understanding here from all of you. Anaya says multiple W's, love to see it. We're confident. And if you're thinking about putting a plus as well, always be honest, right? You're not getting graded on any of this. This is a safe environment, safe and learning experience. So go ahead and participate in the chat. If you have any questions as well, ask those questions. Remember those 3 things that I mentioned at the very beginning of this lesson. We like to have fun, we like to make mistakes, and we like to ask questions. Those 3 things are opportunities for you to learn during these live lessons, or maybe even if you're watching this recording. Okay, Let's take a look at the next slide. Oh, nice. Hi, Hamad. Logarithms. Unfortunately, today's lesson is not on logarithms, but that is coming up in my course curriculum. Bye, Naya. Thanks for joining in. All right, here we go. We have x minus y plus 3 is equal to 0. I want to solve for x and y here. Now, I'm trying to think here. I don't really want to isolate for x because then I'll have to worry about this 3. It looks like I'm going to be isolating for y here. So I'm going to move this negative y to the other side, making it a positive y, and that will be x plus 3 is equal to y. And so whatever I have here, I'm actually going to rewrite this x because it's so close to the arrow. X plus 3 is equal to y. So for every y variable that I see, I'm going to plug in x plus 3. So y here, let's plug in that x plus 3. So we have 3x squared now minus 2x times x plus 3 plus x plus 3 squared minus 17 equal to 0. And now let's distribute and expand. 3x squared minus 6x squared minus 6x. Again, this entire negative 2x needs to be distributed to both terms within the parentheses. X plus 3 squared, I know is x squared plus 6x plus 9. If you want to do this on the side, rewrite it as x plus 3 times x plus 3, and make sure you are distributing all terms. Okay, all terms. Minus 17 is equal to 0. Okay, let's combine like terms. 3x squared minus 6x squared plus x squared. That's just negative 2x squared. Negative 6x plus 6x, those eliminate. 9 minus 17 is negative 8. So, wow, this turns out really nicely because I can add 8 to both sides, divide both sides by negative 2, and I'll get x squared is equal to negative 4. Will this ever work? In the chat, let me know. Will this ever work? Negative 6x and 6x eliminate. The solution is complex. Exactly. The solution here is complex. We will have some imaginary numbers here and things like that. And that's how we know. But in the real number system, we would say no solution. And what does no solution mean between two equations? What does it mean to have no solution between two equations? No solution would mean that these two equations or graphs never intersect. That's what we get. These two equations or graphs will never intersect. And that's the main idea here for all systems of equations. We need to understand we deal with systems of equations because later on in AP Calculus, we'll just be using them to find points of intersection. Points where two functions or two equations meet. Because when they intersect, they must change direction in some way as well, most of the time, or majority of the time. And that gives us very important information. Even in economics, supply and demand, that optimal point is where the supply and demand graphs meet, that point of intersection. That's what systems of equations is all about. And that's why we learned that in algebra. Let's check out this next one. This came out on the SAT. If x comma y is a solution of the system of equations below and x is greater than 0, this is key, what is the value of x times y? So we not only have to solve for x and y, we have to solve for x, y. So keep that in mind, right? We're not done with the problem until we've solved for x times y. Okay, so y is equal to x squared. So let's plug in x squared for this y. We have 2x squared plus 6 is equal to, let's distribute, 2x plus 6. We're going to move everything to one side because we have a quadratic equation. When set equal to 0, we may be able to factor. 6 and negative 6 eliminate. So we have 2x squared minus 2x is equal to 0. When we factor out an x, or let's factor out a 2x as a matter of fact. 2x, we get x minus 1. So x is equal to 0 or 1. But what did we say before? X has to be greater than 0. So 0 doesn't work, x is equal to 1. When x is equal to 1, y is equal to x squared, therefore 1 squared, which is 1. So since x is equal to 1, y is equal to 1, x times y is equal to 1 times 1, which is just 1. All that work to just get 1 as our answer. We love problems like this, don't we? All this work for such a simple answer. Okay, give me a W in the chat if this is making sense, or if you're at least building confidence in this. Give me a plus in the chat if you're still feeling a little bit iffy, you'd like to see another problem, and I do have that one problem left for us. Again, this is quadratic systems of equations. We were given a linear equation here and a quadratic general equation, y equals x squared, just a general parabola, and we found the two x values, x coordinates of the point of intersection, but we wanted when x is greater than 0, so the right side of the y-axis. Let's try this last one out. The functions f of x and g of x create two closed regions. They create two closed regions. Now, what does that mean? This is from an AP Calculus problem. Two closed regions might mean something like this. We meet here, we meet here, we meet here, and this is one closed region, and this is another closed region. This region right here is open because it doesn't close back up. This goes up, this goes down, this goes up, this goes down, an open region, open region. These are what we call closed regions, just like this. So we want to find the points of intersection. So we already know from this graph, if we have two closed regions, that means we will have 1, 2, 3. 1, 2, 3 points of intersection. Let's take a look at where those are. In order to do this, we're going to set the two equations equal to one another. And that's the easiest way to do this because, reminder, when we have a function of x, that's basically just y. So we can set these two equal to one another. 3x cubed minus x squared minus 10x is going to equal negative x squared plus 2x. And let's move everything to one side. Notice how x squared, negative x squareds, they will eliminate. Then we're left with 3x cubed. Subtract the 2x, so it becomes minus 12x equal to 0. There's a really neat way to solve this. These two terms have a common factor. Let me know what you think it is in the chat. What can we factor out from each of these two terms? 3x cubed and a negative 12x. Well, 3 and 12 have a factor of 3. X cubed and x have a common factor of x. So we can factor out a common factor of 3x, leaving us with x squared minus 4. And guess what? X squared minus 4, we call this a difference of two squares. Dots is what some people call it as well. Difference of two squares. Difference of two squares. And that's when we have something like a squared minus b squared, and we get a minus b times a plus b, like this. So here we'll have 3x times x minus 2 times x plus 2. X minus 2 times x plus 2. So we have a product of three expressions equal to 0. Any one of those expressions can be set equal to 0 here. So 3x equal to 0, x minus 2 equal to 0, x plus 2 equal to 0. Now, I know that some of your teachers may have said just flip the sign, but that is not always going to work. That's why I stick to my good habits, build good habits here, right? Before we get to the more complex equations, always we focus on building good habits. Just rewrite it like this every single time, and you'll never have to worry about little gimmicks like that about flipping the symbol. Because later on, let's say you get something like 2x minus 1, and then like 3x plus 5 halves. What are you going to do? You can't flip the symbol anymore. You have to set each of these equal to 0. But when you get that and you've been flipping the symbol every time without actually knowing why we're flipping the symbol, then you're going to get these questions wrong, right? So always build good habits. So important to build good habits before we get into more complex problems. X is equal to 0 here, x is equal to 2, x is equal to -2. Now we want to find all the points of intersection. We have only found the x values. A point consists of an x and y coordinate. So we need to find these respective y values. And I'm going to use g of x here because that seems like the easier function to work with. When we plug in x equals 0, y is just going to equal 0. When we plug in 2, we get -4 plus 4, which is also equal to 0. When we plug in a -2, we get a -4 minus 4, which is equal to -8. So my 3 points of intersection are 0, 0, 0, the origin, 2, 0, and -2, -8. These are the 3 places that the functions f of x and g of x will intersect in order to create closed regions like these. This is not the exact graph of f and g of x, by the way. This is just a sketch, and I wanted to show you what 2 closed regions might look like between 2 functions. Okay, here we go. Put a W in the chat if today's class helped, or if you learned something new, or if you enjoyed your time here by any means. Put a W in the chat. And thankfully, this doesn't have to be over. The learning doesn't have to stop here, because today was just one piece of all my Algebra 2 curriculum through the month of May to the first week of June. You can try My EddSpace for 7 days for just $7. You get full access, and you can cancel at any time. And this is what it'll include. Every week, you get 2 live interactive lessons, just like the one you experienced today. You get 2 of these on Tuesdays and Thursdays, and I'll bring up the schedule in a little bit. And guess what? All of these lessons are recorded. So let's say you miss a lesson, don't worry. You can go back to the recording. You can see the live chat as well of students chatting. And you get to revisit these at any time after the lesson is over. So let's say you didn't cover quadratic systems of equations yet, and your teacher covers it maybe a month later. Then you can go back, November module, quadratic systems of equations, click on it. You can review my entire lesson. You can speed it up as well using the speed up, or you can just look at specific parts that you'd like. You don't have to rewatch the entire thing. Additionally, you have these workbooks professionally designed so that you can structure your learning. You don't have to copy down everything that's on the slide. You can focus on the learning because the workbook is there, the diagrams are there, the equations are there already for you. You don't have to worry about copying down what's already on the screen. After every lesson, you get practice problems, a unique set of practice problems based on each of these lessons that help you to assess yourself, right? Self-assess whether you truly understood the concepts and skills that we learned during that lesson. And don't worry, if you get it wrong, if you get any of them wrong, you get immediate feedback with my video solutions. These are video solutions that I've already recorded of myself doing these practice problems step by step while giving you exam tips along the way. And don't just hear from me. Over 17,000 students have used my EddSpace and succeeded. We have hundreds of 5-star reviews, and there they are. And so if you'd like to join, grab your parents for 60 seconds. Again, this is not a sales pitch. I'm just a teacher. I'll be teaching all these courses, but you do need, we just need your parents to sign off to approve you in joining my courses here at my EddSpace. So here we go. Hey parents, your child just finished a free Algebra 2 lesson and wants to try a 7-day trial. This 7-day trial will help you to fully experience what it's like to be in our courses with the students that are already there, right? With the students that are engaged, just there to learn. They're so locked in every lesson, like every lesson they're learning something new. They're saying that, oh, I just learned this yesterday in class, or, oh, I think I'm going to learn this next class. And it just helps them build confidence, and we're just having fun in there while learning. I know. Imagine just having fun learning in math. Like, that's just unheard of, maybe in my generation, but this new generation is looking a little different with me here at my EddSpace. You get your full money back guarantee and cancel with one click. After the 7 days are up, that 7-day trial is up, it's only $149 a month after that. That's for 7 to 8 lessons per month with all the recordings, access to all the recordings, the workbooks, the video solutions, the practice problems, everything. Everything for just $150 a month. Tutors cost at least starting from $50 an hour. That's just 3 sessions. They're not recorded. I mean, it's quite a no-brainer there. And for $7, again, this is all you get, right? 2 times, 2 lessons per week, fully recorded, workbooks, practice problems, video solutions. Honestly, enough said. Here's the lesson schedule. Algebra 2 meets on Tuesdays and Thursdays, 6 p.m. Pacific time, 8 p.m. Central time, 9 p.m. Eastern time. Each lesson is 55 minutes. And to protect you from any risk, we provide a full refund guarantee at no risk. So if you are interested, scan this QR code to start your 7-day trial with me next week on Tuesday or Thursday. And you can also go to, if the QR code is not working, you can also go to this link that I'm putting into the chat. And I will stay on for another minute or so to answer any questions you may have. But thank you for your time today. Thank you for checking us out. And I look forward to seeing you soon and getting you started with your journey at MyEdSpace with me. All right. Well, see you soon. See you next week. Bye-bye, everyone.